Hello, everybody. This is math used basically for high school Algebra 1, but it's also can be used if you need to understand standard form and the quadratic formula. Okay, so let's take a look here. This is standard form, and standard form just means you're going to do ax plus bx plus c. And over here we have this written that each one of these x's is actually saying this is x, the first value of x, this is the second value of x, and here is your constant. Okay, what's constant? The constant term is the term or the number that stands alone, meaning there is no variable. If you look over at the rest, you have a variable here, and you also have a coefficient in front of it. So let's take a look at this here. This coefficient is 2, this coefficient is 7, and your constant is 28. People ask, what does this have to do with anything? Well, this is just the way it's written, and if you look at this, this is your A term, this is your B term, and this is your C term. Okay, so let's move on. This is just a quick review. You can go ahead and download this. A negative times a negative is a positive. Please make sure you remember that because a lot of people get that confused. They keep thinking that because it's two negatives, you are turning this into a negative, but that is only if you are adding or subtracting and you're multiplying and dividing. So this is it for multiplying and dividing, and we'll do how you add and subtract on a separate in a separate video. Positive times a positive has to be a positive because that's all you have. Once again, if you understand, the only thing that really changes is this. This is the thing that confuses everybody, that a negative times a negative has got to be a positive. That's what's confusing. Okay, this is negative times a positive is a negative, positive times a negative is a negative. So, okay guys, we're moving on. All right, here's your quadratic form. It says use a quadratic formula to find the roots or the equations. Your roots are going to be what x's value is. So if you ever see this root here, let's just go on ahead and write this here. It means x's values. And sometimes when you're using the quadratic formula, which is seen up here, you might have two values, and you can ask in a second why you might have two values. The reason that you have two values is because you have a plus or minus sign up here, meaning that once you take whatever this term is or this number, which in this case is going to be b, b is going to be 5, I'm sorry, which is negative. So you'd have negative 5 plus or minus the square root of 5 squared minus 4ac. You would then have to turn around over 2a. You would have to then find out its roots. And because you have 2, you might have both a negative value and a positive value. Okay, so let's go right in here. Here's your equation here. X squared plus 5x plus 14 equals 0. Okay, so when you write this into your form here, in your standard form, you have ax plus bx plus c. So you don't have anything here. But it is understood that when x is alone, in this case it's x squared, it's implied it's a 1, although it's individual. It's invisible. I'm sorry, not individual, but it's invisible. So you have a equals 1, b equals 5, and c equals 14. Okay, so just try to visualize and picture what's going on here. Okay, here's your quadratic form. How do you memorize this? Well, it gets hard. Just remember negative b plus or minus b squared 4ac And then this will come, this 2 times a, or 2a will come later. So if you can just remember the first part, this here is called the discriminant. But if you can remember negative b plus or minus square root of bc minus 4a, and you know it's c afterwards, you can get that done. Okay, here are our terms. So now we can go ahead and multiply. When we get ready to multiply, when we first look at it, we have a mess here. Let's not forget our rules of PEMDAS. I learned them as please excuse my dear Aunt Sally. Doesn't really matter how you memorize them. As long as you understand, you take care of your exponents first, because this E represents what? Exponents. So here you are, doing your exponents. Which is 25 minus 4 times 1. It's negative 4, by the way, but 4 times 1 is 4. Okay, times 14, and you can go ahead and make this negative if you want to over here, but I left it positive just so you'd understand what's going on. Okay, and then see, because I left the minus sign over here, so you have negative 4 times 14, and then you have the square root of 25 over minus 56. Why are you leaving everything under the square root? You have to take whatever's over the square root first. So if you had 9, square root of 9, you'd have that equals 3. You'd have the square root of 16, that equals 4. So your square root, everything under here has to be taken care of first. And by the way, these are called perfect squares. I don't think you're going to have a perfect square here, so we're going to have to leave it. When you do not have a perfect square, like here, because here's what's really going on. 56 plus 25 is really what you're doing, because it's saying take positive 25 and subtract 56 from it. Or you could say add 25 and negative 56. They mean the same thing, but what's happening here is you have 31 and it's negative because you're adding. So now you have a negative square under here. You will learn later, maybe towards the end of Algebra 1, but definitely in Algebra 2, there is a way to multiply. But right now, let's not worry about that. This isn't a perfect square, so we're going to leave this. Okay, these over here, perfect squares, and so they get simple numbers. And this over here is not a perfect square. Okay, so that's going to be your answer. Now, here's the situation. If you were really going to do this so that you could graph this equation, you would have negative 5 plus or minus the square root of negative 31. So you could either go, if this were a perfect square and you had 9, you would actually go 5 plus 9 over 2, and then your answer would come out, subtract 5 from 9 is what this means, or add negative 5 to 9, and you'd actually come out with 4 over 2, and then you would have 2. See, that's what that plus means. And also, if you were to have this negative 5 with this sign here as a minus, sorry guys, I keep doing that, as a minus here, you would have negative 5 minus 9. Let me go ahead and change that. So that would be minus 9, which is going to give you negative 14 over 2, which is going to give you negative 7. Okay, that's the concept. You don't have a perfect square, you have this, so most times your teacher will let you leave that, and if you were going to graph it later, what would actually happen is this would have to be you'd have to try to do this as an irrational root and try to figure that out. But right now, your teacher doesn't want that. And what you'd have here is x equals this value, and you just leave it. Let's move on, do another one over here. And once again, here you have your standard form. And here you have nothing here for b. It's b squared plus 4b plus 4. So you have 1b plus 4b plus 4. Okay. And here are your coefficients, and your constant is here, c equals 4. So now here's your quadratic formula. Now let's add them in. And what we have here is all these awful numbers, and I call them awful because when you're first learning this, it's hard to do. This is negative b, so you're going to make this a negative 4. This is square root 4 squared. You already know is 16, but here you want to leave it minus 4 times the a term here, which is 1, times the c term here, which is a positive 4. So here you have negative 4 plus or minus 16, and then this negative 4 times this keeps this negative times a positive. Now look what happens here. You have negative 4 plus or minus the square root of 16 minus 16, which you know is 0. You cannot have a square root of 0. Okay, 0 is one of those numbers you can't square. And if your teacher went over square roots of 1s, that's another one. It's just plain 1. Excuse me, so you can't have that. That then becomes negative 4 plus or minus 0. Well, guess what? Negative 4 plus 0 is negative 4, so it's left alone. Okay, and this plus or minus sign here is kind of canceled out, so it's negative 4 over 2. So you only have one root. And you only have one possible to an equation. And your teacher is going to explain that to you, why you have one root. Your teacher is going to expect you to know. So x equals negative 2 only. Okay, and they ask you to find roots sometime because usually you have 2. You can't do anything else because it's just negative 4 over 2. This is divided. This is negative 4 divided by 2, and then we simplified, and that's your answer. Okay? So let's move on. This is just changing using the same formula, but this time we wanted to rewrite it where b is equal to negative 4 and c is equal to 4. Well, see, here's the concept. Now watch this. This is a negative times a negative, 4 plus or minus 4, and guess what? This is negative squared minus this here, but see this negative, once you square a negative 4 times a negative 4, I'm sorry, you get a positive 16. So once again, you have a 16. This is 4 times negative 4, which is a minus 16. It's still 0. But guess what? Over here is the difference. It's positive. So now you have 4 plus or minus 0, which is 4 minus this. You have 2. But because of this 0, you still only have one root. So if you stay tuned for our next video, you're going to see how you can have 2 roots. Thank you for watching. JacobitsLearning@gmail.com if you have any questions. If you have a chance, like us.